Hello everyone, my name is Abhishek and I'm mathematics faculty here at AskIITians. So today we are going to start chapter mensuration, and this is the lecture number 1 of this chapter mensuration. So before we start or before we delve into the topics, let us visit or let us understand the weightage of this particular chapter as far as your school and Olympiad examination is concerned. So if I talk about school examination, then in school examination, you can expect questions of around 11 marks from this particular chapter. Although since in class 8, the examinations are internal in nature, so that might vary a little for from school to school actually. So be prepared for that. And if I talk about Olympiad examination, then this is one of the important chapter for Olympiad examination, and you can expect questions around 3 to 4 questions from this particular chapter. And why this chapter is important? This chapter is very important because you are going to study mensuration in ninth also. You are going to study mensuration in 10th also. So because of these reasons, this chapter is quite important. So it's very important for you guys to be very attentive while we discuss this particular chapter, and ask me wherever you feel you haven't understood anything while I explain that particular stuff. All right. So which topics are we going to cover in today's session? So if I talk about today's session, in today's session, we are going to cover these 3 topics, I would say. The first topic is what is how do we calculate the area of a square and rectangle? Although we studied this thing in our junior classes as well, but here we will, you can say, revise that concept, and we are going to do few problems as well based on this particular concept. The second thing or the second topic that we are going to cover is area of trapezium, how we calculate the area of trapezium, what is the formula that we have for the area of trapezium, and how we got that formula as well as the application of that formula. That is what we are going to cover. Now, before we start our topic, it's very important to understand, does this particular chapter has any relevance to, you can say, the practical words. It has a lot of relevance, I would say. You like every day we observe something which is a square in shape or which is rectangular in shape. For example, if you talk about you can say kite, right? Or you can say, if you talk about a deck of card, then the playing cards are rectangular in shape. If you talk about matchbox, then the face, if you observe the face of a matchbox, then that is also rectangular in shape, right? So we come across these shapes a lot in our real life as well. That makes this particular chapter quite important, as well as it has physical relevance as well. So that's it, right? So let's start with our first topic. So before we delve into the formulas that we have in this chapter, it's very important for us to understand what is the meaning of area. What's the meaning of area? So I'm going to draw a few random figures for us to understand what is the meaning of area. Okay, let's say this is any figure you have. All right, this is any closed curve that you have. So if I talk about the area of this particular figure that I have drawn, area means this portion that is enclosed by this figure, right? The portion that I'm going to highlight in yellow color, this portion depicts the area that is enclosed by this particular closed curve, right or not? Similarly, if I take, let's say, one more example, if I have, if I have, let's say, if I have this, okay, this figure, okay. So if I have this figure, then what is the meaning of area that is enclosed by this figure? Then area means we are actually talking about what? We are talking about this portion, like the two-dimensional space that is enclosed by this particular figure is going to constitute to what we call as the area of this figure. So here this yellow portion depicts the area, okay. Here that yellow portion depicts the area. And if you talk about the second figure, then In this second figure, this greenish portion depicts the area that is enclosed by this particular figure. So even if you read this definition or the statement which is written, it says area is the size of a two-dimensional surface, right? So here the two-dimensional surface that we are talking about is rectangle and square. Why they are called two-dimensional? Because they have got two dimensions. One is length and the other one is breadth. Okay. And how do we define it? It is defined as the amount of the two-dimensional space which is occupied by an object. So if I talk about, let's say, if I talk about this rectangle which is given to me, all right. So if I talk about this rectangle, then in this rectangle, this entire portion which I am highlighting here, this depicts the area, or it denotes the area which is enclosed by this particular rectangle. On the other hand, if I talk about this square that I have, then this area which I am highlighting in yellow color, that depicts the area which is enclosed by this square which is given to us. Okay. And we already studied how do we calculate the area of a rectangle or a square for that matter, right? If you have to calculate area of a rectangle, then you need to know the length and the breadth of that particular rectangle. So if this is rectangle, guys, just to tell you, okay, this is rectangle. So if I assume the length of this rectangle to be L and the width or the breadth of this particular rectangle to be W, then for the rectangle, the area is given by length into breadth. Always remember, where L is representing the length of this rectangle, W is representing the width or the breadth of this particular rectangle. Clear? On the other hand, if you're talking about a square, this second figure depicts a square. Okay. Then square, the area is given by side square. Okay. A square means the area is given by side square. And if you talk about the perimeter of both the figures, I will tell you the perimeter as well apart from area. So here area is given by a square, where a is representing the side of the square. If you talk about perimeter of rectangle, okay, then what is the perimeter of rectangle? First, we should understand what is the meaning of a perimeter. A rectangle has got four sides, right? If you add the length of all the four sides of this rectangle, then the value which you are going to get as a result, that value is called the perimeter of the rectangle. So here, because if this is L, the opposite side will also be L. And if this is W, this side is also going to be W. So if you are talking about perimeter, then that is always given by twice of length plus breadth. Okay, because you will be adding length two times, you will be adding breadth two times. If you talk about a square, because in a square all the sides have same dimension, so you are adding that side four times, and when you add a side four times, the sum is going to be 4 into side. So what will be the perimeter in this situation? In this situation, the perimeter is going to be 4 into side. Clear? I hope the meaning of area, the formula for area, both for rectangle and square, the formula for perimeter, both for rectangle and square, that's very clear to everyone. Please go through it and ask me if you have any doubt in it. And also one more thing I would like to tell you guys, because I have seen the kids make that common mistake whenever they solve any problem. See, whenever you are, whether you are calculating area or whether you are calculating perimeter, it is very, very important for you to write the unit. Okay. If the unit is not given, you can always write UNIT as a unit. Okay. If the unit is given, be it centimeter, be it meter, millimeter, anything, you should write the answer in terms of that unit. And if the unit is not provided, you can leave it as a unit, like after writing unit or unit square, it depends on what they have asked you. Is that clear? Clear? All right. Now we have area of trapezium. This is very, very important. Okay. And I'm also going to tell you what is a trapezium. Like, we are going to revisit that concept. And apart from that, I will also tell you how we got this area of trapezium. So what is a trapezium actually, or what is the property of a quadrilateral which makes it trapezium? if I have to say it another way, then you can say trapezium is what? It's a quadrilateral with one pair of opposite side, isn't it? It's a quadrilateral with one pair of opposite side, with one pair of opposite side. So if you have a quadrilateral which has one pair of opposite side, then you can say that that quadrilateral is a trapezium. So here in this figure which is given to you, you have this AB which is parallel to CD. I am writing here. AB is parallel to CD. Clear? And what is the formula for the area of a trapezium? The area of a trapezium is given by 1 by 2 into sum of parallel side into height. I am writing here. How we got that? That we are going to discuss. The area is given by 1 by 2 multiplied by sum of parallel sides, okay, multiplied by height. Okay, if you solve it, you automatically get the area of trapezium. Now, how we got that formula for the area of trapezium, that is what we are going to discuss. All right. So here, this ABCD that we have, this is a trapezium, guys. Okay. We have to derive the formula for the area of trapezium here. So check out how we can calculate. So to derive the formula for area of trapezium here, we need to do one construction. And that construction is you need to draw perpendicular from these two vertex, which is A and B, to the side which is opposite to it. You can call it M and you can call that point as N. Okay, so I am writing what is the construction that is done. So construction is you need to draw AM, that is perpendicular to DC, and BN, that is perpendicular to again DC. That is the construction which is done from our side, guys. All right. Now, what will happen when you will do this construction? This entire figure which you have here, it will get divided into three different figures. Okay. I'm going to call this area as A1. I'm going to denote this second area by A2 and this third area by A3. All right. So if you want to find out, the area of this quadrilateral that you have ABCD, then to find out the area of this quadrilateral ABCD, we can add the area of triangle ADM, okay, to area of this rectangle ABNM, okay, and to this we can add the area of the third remaining triangle, which is BCN. If you add these three areas, you will automatically get the area of the trapezium which is under consideration. So let us calculate and see what are we going to get. Since this triangle that you have ADM here, that's a right triangle. So if you want to find out the area of a triangle and you know the base and you know the perpendicular, then you can use the formula that is half base into height. So if I talk about this triangle ADM, the area will be given by 1 by 2. Base, which is DM, and what is height? Height is AM. Clear? If you talk about this one, okay, that is this rectangle ABNM that you have, we just studied how we can find out the area of any rectangle. The area of any rectangle is always given by 1 by 2 into, not 1 by 2, sorry, length into breadth. All right. So here we are going to have MN into AM, you can say. All right. And if you talk about this figure, that is BCN. BCN is again our right triangle. So the area will be given by 1 by 2 into base, which is NC, into height, that is BN. Is that clear? Now we are going to substitute the value that we know. For example, we are aware of the value of AM, which is H. We are aware of this value AM, which is H. And we are aware of the value, this BN, which is again H. So we are going to substitute it. So we will get 1 by 2 into DM into H. 1 second. You will get 1 by 2 into DM into H, plus you will have MN into H. You will have MN into H, plus you will have, you will have 1 by 2 NC into H. You will have 1 by 2 into NC into H, right? Now what can be done? You can first take 2 as an LCM, and after that you can take h by 2 common. So if I take 2 as an LCM here, what will I get? I will be getting dm into h. Okay, that is added to mn into 2h, right? Plus you will have here nc into h. Okay, so now we can take n by h by 2 common. If you take h by 2 common, inside the bracket you are going to get dm, plus you will be getting twice of mn. Okay, plus you will be getting nc. Okay, since here what do we have? We have twice of mn. What is the meaning of twice of mn? That means we have two values of mn, so we can write this twice of mn as mn plus mn. So you have h over 2 here, that is multiplied to dm. Okay, plus this twice of mn, it can be written as mn plus nc. Okay, that's how we wrote it. Now we can write this nc here with the first two terms, and this mn I am going to replace, you will see with which value. If you observe this figure, you will see that mn that you have here, it's equals to ab, because this abnm, this is acting as a rectangle, so that mn we are going to replace by ab. So you will have h by 2 here, you have dm plus mn, dm plus mn plus nc, plus mn has been replaced by ab. Now if you add these first three terms, dm plus mn plus nc, what will you get? Dm plus mn plus nc is going to give you dc. Clear? So you will have 1 by 2 into dc into sorry, you will have, I'm writing here guys, so that area you have, that will be equals to what? That will be equals to 1 by 2 multiplied by h. The sum of these three terms is dc and plus ab, right? So dc and ab that you have here, these two are the parallel sides of this trapezium. So we can say that the area is given by 1 by 2 into sum of parallel sides, sum of parallel sides into height. Okay, so that is the formula for the area of the trapezium that is under consideration here. I hope it is very clear to all of you. If you have any doubt in this, you can if you still have any doubt in this, you can ask me guys. This is the formula for the area of any trapezium, and that's how we got it. Okay, because after this we will learn the application of the formula that we studied for the area of rectangle. We will learn the application for the area of square and area of trapezium. Is it done? All right. Now we have the application of the formula that we discussed just now. Here, let's see what we have to calculate. You have to find the area of rectangular blackboard, which you can see on your screen, whose length and breadth are provided to us. Length is 120 centimeter and the breadth is 100 centimeter respectively. So this is super easy. So we are provided a rectangular blackboard, and we know how we calculate the area of any rectangle. Area of any rectangle is always given by length into breadth. So here we are provided length. We are provided length, that is L, which is equals to what? That is equal to 120 centimeter. We are provided breadth. So that breadth, which is same as B, that is equal to 100 centimeter. And what do we know? We know what is the formula for the area of rectangle. We know that the area of any rectangle is always given by L into B. So if you multiply it, you will get 120 into 100 centimeter square. So that is going to give you 12000 centimeter square. And what point I was discussing or emphasizing on in the very beginning is this point, that it's very, very important to mention the unit. If you forget to write the unit, then there are chances that you might lose around half mark for that. Clear? So you can go through it. Understood? Okay, so here you can see they have calculated this area in terms of meter. So we are provided the length of this blackboard, which is equal to 120 centimeter. And if you have to convert 120 centimeter into meter, what you need to do is you need to divide this 120 by 100 and you will be getting 1.2 meter. And that's exactly what they have written here. The breadth is provided to be equals to 100 centimeter, and 100 centimeter is 1 meter, we all know. And we also know that what is the formula for the area of any quadrilateral, area of any rectangle. The area of any rectangle is given by L into B. So we used that formula, and using that formula they got the area to be 1.2 meter square. So it entirely depends on you whether you want to calculate it in terms of centimeter square or whether you want to calculate it in terms of meter square. That is entirely up to you. No marks will be deducted until and unless they have asked you specifically that please calculate it in any specific unit. Clear? All right, so now we have a problem which is based on trapezium. If the length of the parallel sides of trapezium are in this ratio 3:2 and the distance between them is 10 centimeter, and we are also provided what is the area of trapezium, then they are asking you what is the length of parallel sides. So for that, let us first draw a rough figure. All right, let's say this is A, B, that is C, and this one is D. So what are we provided? We are provided that the length of the parallel sides are in the ratio 3:2. So here in this trapezium, the parallel sides are AB parallel to CD. And because the ratio is 3:2, so we can say that here we are provided that DC ratio AB, that's equal to what? That's equal to 3:2. Why I have taken here DC ratio AB? I have taken here DC ratio AB because DC has more length if you or the length of DC is more if you compare it with the length of AP. So this is provided to us. So if this is provided, you can assume the length. Okay. So I'm going to assume, let's say this DC is equal to what? That is equal to 3x and that AB is equal to 2x. Clear? So this DC, this AB is equal to 2x unit or centimeter, and this DC is equal to 3x. Clear? Apart from that, we are provided that the distance between them is 10 centimeter. So this value is given 10 centimeter. Okay, or the height. You can call it M. All right. So we know how do we calculate the area. What is the formula for area? The area is always given by 1/2, that is multiplied to sum of parallel side. So here the parallel sides are AB and CD respectively, multiplied by height, and height is AM here. The value of area is provided 325, so it will be 325. That is equal to 1/2 into sum of parallel sides. So you will be getting 2x plus 3x. All right. And what is the height? Height is 10. So this 2 will cancel this 10 5 times. This 5 will cancel this 325 how many times? 65 times. So what will you get? You will get 65 is equal to 2x plus 3x, which is equal to 5x. So you will be getting x is equal to 13. Clear? So we got the value of x, that is equal to 13. Therefore, we can easily find out the value of DC and AB. So what will be the value of DC? DC is equal to 3x. That means that will be equal to 3 into 13. And 3 into 13 is going to give you 39 centimeter. And if you talk about the other side, which is AB, that's equal to 2x. So you will be having 2 into 13, and 2 into 13 is equal to 26 centimeter. So we have got the length of both the sides, both the parallel sides we have of this trapezium. It's just that we use the standard formula that we discussed just now. And after that, we substituted the value. And after the substitution of the value, we just simplified it and got our answer. I hope it's clear to all. Please go through it and ask me in case you have any doubt or any query in this, guys. Is this clear? All right. So here they have given this solution for your reference. So what they did is they assumed the common ratio to be x. So if the common ratio is x, then you can assume the length of parallel side to be 3x and 2x centimeter respectively. And the distance between them is already provided to us in the problem, that is 10 centimeter. And area is also given to us, which is equal to 325 centimeter. So we know the formula for the area of trapezium, that is half into sum of parallel side into height. So they substituted the value. So they got 325 is equal to 1 over 2 into 3x plus 2x into 10. So you will be getting 325 is equal to 5x into 5, because this 2 will cancel this 10 5 times. And after the simplification, the value of x which you are going to get is 13. All right. So what will be 3x? 3x will be 3 into 13, that is 39 centimeter. And 2x will be 2 into 13, that is 26 centimeter. And that's exactly what we got when we did the calculation. Clear? Done? All right. So now what is the next problem? Next problem says you have a square carom board. That's an important point. And the perimeter is provided to be 320 centimeter. You have to calculate its area. Correct? So we know that when we are talking about square, then all the sides are of same length. And here the carom board that we are talking about, it is a square in shape. So the length, length of all the side will be same. Okay, so I am going to assume the length of this side to be like, let's say x centimeter. So if this side is x centimeter, then it is very clear, or it's very common that all the other sides will also be x centimeter. Clear? So this is x, this one will also be x, correct? And what are we provided? We are provided the value of perimeter, which is equal to 320 centimeter. So we are provided perimeter, and that perimeter is equal to what? That is equal to 320 centimeter. All right. We discussed this just now, that how we calculate the perimeter of any square. If you have to calculate the perimeter of any square, you just need to multiply side 4 times. Not 4 times, you need to multiply side with 4. Okay. So if perimeter will be given by 4 into side, so that value is given to be equals to 320. Clear? So what is the side that we have assumed? We have assumed side to be x. So you will have 4 into x, that is equal to 320. So this 4 will cancel this 320 80 times. So what is the value of x? We will have x is equal to 80 centimeter. Okay. So we got the side of this square. This 80 centimeter is what? This 80 centimeter is actually the side of this square, which is under consideration here. And since we have got the side of a square, we can easily calculate its area, because the area of any square is given by side square. Okay. Therefore, if we have to calculate area, so what will be the area? Area is side square. Clear? So what is side? Side is 80. So it will be 80 square. 80 square is 6400 centimeter square. I told you it's very, very important to write the unit whenever you are calculating, be it area or whenever you are calculating perimeter. Writing unit is very important. Okay. Clear? All right. So that's exactly what they have written here. You can see this solution is for your reference. Since the carom board is a square, so all its side will be of equal length. And we know that the perimeter of the board is 320. Hence, if you have to calculate the length of each side, you have to divide 320 by 4 and you will be getting 80 centimeter. Why this division by 4 has taken place? Because the perimeter is always 4 into side. If you move that 4 to the other place, to the other side, you will be getting 320 by 4, which is same as 80 centimeter. And if you have to find out area, you need to multiply side 2 times. So you will be getting 6400 centimeter square. And that's exactly what we got here. Clear? All right. So this is also a good problem. This says you have to calculate area of unshaded part. What is unshaded part? Unshaded part means this area needs to be calculated. Okay, this is the required area. Clear? Okay. So if you want to, all right, I'm going to call this area as delta 1. Let's say this as delta 2. Okay, this is just a name delta. Okay. So if you want to calculate the area of unshaded part that you have, and let me name this rectangle as well, A, B, C, and that is D. So if you want to calculate the area of this shaded part that you have, unshaded part, sorry, then what you can do is you can calculate the area of this bigger rectangle which is provided to you. And from that, we can subtract the area of this rectangle, which I have, whose area I have denoted by delta 1. And then we can subtract the area of this square, whose area, whose side I have denoted by, whose side has been given equals to 4 centimeter, and area has been denoted by delta 2. Okay. So if we have to calculate area of unshaded portion, area of unshaded part. So to calculate area of unshaded part, what you have to do, from the area of this rectangle that you have ABCD, okay, we can subtract area of this smaller rectangle which I have denoted by delta 1, and also you need to subtract the area of a square which has been denoted by delta 2. If I talk about this rectangle that is ABCD, we need to know the length and breadth. So breadth we already know, which is 10 centimeter. So what will be the length? Length will be equal to 10 plus 2, which is equal to 12 centimeter, right? So to calculate area of ABCD, you need to multiply BC and CD, let's say. Okay. To calculate the area of delta 1, you need to multiply length and breadth. Length is 6 and the breadth is 2. And to calculate area of delta 2, which is a square, you need to multiply side 2 times. So you will be getting 4 square. Clear? What's the value of BC? BC is 8. What is CD? CD is 12. This will be 12 and that would be 16. Clear? So you are going to get 96 minus 28. Clear? So if you subtract 28 from 96, what will you get? 16 minus 8 is 8 and 8 minus 2 is going to give you 6. So you are going to get 68 centimeter square as the area of the unshaded part of this figure. If they ask you to calculate the area of the shaded part, that means you just need to calculate the area of delta 1, which is representing rectangle in this situation. You need to calculate the area of delta 2, which is representing square in this situation. Add both the areas and you will get the area of shaded part. On the other hand, if you have to calculate it for unshaded part, then from the area of this bigger rectangle which you are given, you have to subtract the area of the rectangle denoted by delta 1 and the area of square that has been denoted by delta 2. If you do the calculation and everything properly, you will for sure get the answer. Clear? So this problem involves the application of the formula of area of rectangle as well as the area of square both. Done? All right. So here we have 3 questions that you have to try as a homework, guys. So these 3 questions are homework for you. 1, 2, and 3. In case you come across doubt from in any of these 3 problems, feel free to discuss with your askIITians expert. And before we wrap up this session, it's very, very important to revisit what we did in today's session. We started this because the name of the topic was mensuration. So we were supposed to play with the different two-dimensional figure in this. And what are the topics that we covered? We covered 3 topics mainly today. First is we discussed what is area, what's the meaning of area. The second thing we discussed is what is the formula for the area of rectangle and a square. The third thing we discussed is what is the formula for the area of trapezium. We also derived that if the formula for the area of trapezium. And after that, what we did is we practiced problems based on all the 3 topics that we did. And I hope all the problems are very, very clear to you. And these 3 problems that you have in front of you, these are completely based on the topics that have been covered in today's session. Here you can see the answers also, just to cross check your whatever answer you are going to get, you can cross check from here. In case you do not get the correct answer or your answer do not matches what is given here, you can always contact your askIITian expert and we will help you out. So that is it from this session. Thank you so much for attending. Have a great day. I'll see you all in the next session. Goodbye.